All right, so now we're going to fill out our learning card on comparing data sets. So we're going to look at shape, outliers and unusual features, center, and spread. So that's why sometimes we'll say SOCS, shape, outliers and unusual features, center, and spread. So we can start off with shape. So let's take a look at all of these different shaped graphical displays up here at the top. This first one right here has a tail to the left side, so that's why we call this skewed left. Now another name for being skewed left is negatively skewed. Those two terms mean the same thing. Now if I jump over and look at this one here, this one is going to be skewed right or positively skewed. And again, this one is skewed right because there's a tail on the right hand side, or positively skewed. Now in the middle here, we have a bell-shaped or mound-shaped curve. And then another way to describe this is to describe it with the term, describe it as being symmetric. You can see that the left side and the right side look the same, so it is symmetric. Now, all three of these would be considered unimodal because there's one peak. So those are different ways to describe its shape for these different types of graphs. Now, over here, we have some different things that are going on when it comes to the shape of a distribution. This particular distribution has a peak and then a valley and then another definite peak. So when we see a peak and a definite valley and another definite peak, we would call this bimodal. And when we see something that is bimodal, something's going on here. We really should take note of that and actually start to consider treating this as two separate distributions. That's why thinking of the context of a situation is always important. When you are comparing or describing data sets, you always need to make sure that you talk in context. And don't just say the data is this or the graph is this. It should always be in context for whatever problem you're talking about. So if we're talking about test scores, we should say the distribution of test scores appears to be bimodal. And the same thing with these different shapes. Always talk in context, very important. Well, what about this last one over here? We would say that this particular graph, not all of the bars of this histogram are exactly the same height, but we would say this is symmetric. Actually, we would say that this is uniform. We might be able to say that this is symmetric as well, because if we put a line of symmetry down the middle, the left side looks very similar to the right side, but this would be a uniform and symmetric distribution. All right, what about outliers and unusual features? Well, in this particular case, if we look at this histogram, this right here is a potential outlier because it's separated by a gap. There's a gap here, which gaps, by the way, are unusual features as well. But because of that gap, this one value over here by itself might be an outlier. Now, the important thing to keep in mind when we talk about outliers, unless we actually find fences with the interquartile range, then we would want to say that this is a potential outlier. So again, if you don't actually do the calculation to find the fences to determine if something is an outlier, but it looks like it might be an outlier, then you should use the term potential outlier and not just outlier by itself. Now in this graph over here, one of the unusual features that we see is that there is a gap. There's a big gap in the data right here, so we need to make note of that. Now, in addition to recognizing where the gap is, or that there is a gap and where the gap is located, it's also important to think of the context. Why is there a gap there? If you see a question that asks you to compare or describe data and you have a gap, then you should be thinking about why that gap is located there and how you can use context to kind of explain why it is there. Then finally, we get to center and spread. And what we're going to say down here is with center, we have the mean and the median. Mode really is not used to describe the center very often. And with spread, we would use standard deviation, interquartile range, or range. So when do we use which? Well, if we have a symmetrical distribution, then we are going to use the mean to describe its center and standard deviation to describe its spread. So again, if something is symmetrical, the center is best described with mean and the spread is best described with standard deviation. So like with this bell-shaped or mound-shaped distribution, it's symmetrical. Use the mean and standard deviation. For this uniform distribution, it is symmetrical. So use mean and standard deviation to describe its center and spread. Now, what if we have something that is skewed? Well, if it's skewed left or skewed right, or this one right here looks like it's skewed to the right, we would want to use the median as the best way to describe its center, and either interquartile range or range to describe its spread. So we've got this skewed left distribution up here at the top. With this skewed left distribution, we would use the median to describe its center, and either the range or the interquartile range to describe its spread. Same thing for this one here, and the same thing for this one here. Now, what if we have a bimodal distribution, or we have one that's like this? This one would be in the middle, bimodal, because of this gap as well. In this particular case, you really should not use the mean or the median to describe its center, because in this bimodal distribution, the mean and the median are going to be right in here, okay? But this is pretty symmetric, so they're going to be right in here. Well, that's where the least amount of data is located. And even in this one down here that has the gap, we don't want to use the mean or the median. That can be deceptive because of the mean and the median might land in this gap. So whenever you have two distributions like this, or excuse me, whenever you have a distribution that's bimodal and there's this dip in the middle or a gap in the middle, it should really be treated as two separate distributions, and treating it as one distribution and talking about the mean or the median could be a little bit misleading. So hopefully this helps helps give you an idea of how to use SOCS, shape, center, spread, and unusual features to help describe and compare data sets. Have fun in your stats class.